Hi friends, Namaste. Welcome to our channel Vignan Junior College. Today again I want to explain the applications on path length and displacement. Already in the last class we discussed about path length and displacement. Now today I want to explain their applications. Listen to me. As it is physics class, in that I want to explain path length and displacement applications. Now here you observe this, a particle moving along the circumference of a circle, its diameter is equal to 10 meters, its diameter is 10 meters, observe this, diameter 10 meters, therefore its radius r is equal to 5 meters, a particle moving along the circumference of a circle in this manner. Now for complete revolution, what is the distance travelled by the particle? Nothing but path length travelled by the particle. For this complete revolution, tell me what is the path length travelled by the particle? Path length or distance nothing but total length of the path travelled by the particle. Its total length from here to here, total length nothing but circumference. What is the formula for circumference of a circle? 2 pi r. Circumference of a circle, it is 2 pi r. But r is equal to 5 meters, therefore 2 pi into 5. It becomes 10 pi meters. Its circumference 10 pi meters, so its path length is equal to 10 pi meters. Okay, now we are going to calculate its displacement. Now we are going to calculate displacement covered by the particle. Tell me what is meant by the displacement. Don't say it is the shortest path travelled by the particle. It is final position minus initial position. Displacement nothing but final position minus initial position. What is its initial position? A. What about its final position? Also A, because it completes one revolution. So again it reached to its initial position. So displacement nothing but final position minus initial position, both are coincides with each other. So displacement becomes 0 meter. Displacement is 0 meter. Remember that. Now for half revolution, if the particle travels from A to B only, for half revolution, consider only half revolution. For that half revolution, we are going to calculate its path length or distance. Now what is meant by distance? Total length of the path travelled by the particle. What is this total length? Half of the circumference. Circumference 2 pi r. In this only half, that is half of the circumference nothing but 2 pi r divided by 2. It is 2 pi r divided by 2 nothing but pi r. Pi r. But it is equal to pi into r means 5, which is equal to 5 pi meter. Now what about displacement? Displacement nothing but final position minus initial position. Final position minus initial position. Remember that. Now you consider this is x axis. Now its position is taken as 0, 0. Its position is taken as 10, 0. 10, 0 or it is 0, 10. That means initial position 0, final position 10. Now what is the difference? Final position minus initial position 10 minus 0 becomes 10 meters. Displacement 10 meters. Distance 5 pi meters for half revolution. Remember that. In this also displacement here 0, but path length is not equal to 0. Already in the last class we discussed that distance may be positive, distance always positive, distance always positive, it never be negative, it never be equal to 0. Displacement may be positive, may be negative, may be equal to 0. Now, next one. Next, observe this. Here, a particle travels from point A to point B only. A particle wants to travel from point A to point B along the circumference of a circle. Along the circular path, it wants to travel from A to B. A to B. Okay. Now, for that journey, we are going to calculate distance. For that journey, A to B only, we are going to calculate the distance travelled by the particle. Now, how to calculate the distance? While the particle travels from A to B, the line joining from O to A subtends certain angle theta at the center. It subtends an angle at the center. I am assuming it is theta. Now, you tell me what is path length or distance travelled by the particle? Path length nothing but actual length of the path travelled by the particle. Actual length is this one. Actual length, that is here it is arc length. That means distance nothing but arc length of AB that we want to calculate. Arc length of AB. Already in your 10th standard that you know that arc length nothing but r into theta. Arc length nothing but it is r into theta. You must remember that theta should be in radians, not in radius. Theta should be in radians. Remember that. This theta should be in radians. You must substitute that theta in terms of radians, because always we want to use SI units. SI unit of angle, radian. That is, you must substitute the theta in terms of radians. Remember that. Now, for this journey, calculate displacement travelled by the particle. What is meant by the displacement? It is final position minus initial position of a particle. Final position minus initial position of a particle. It is initial position and it is final position. It is initial position and B is the final position. Now, the difference between these two we are going to calculate. The difference between those two nothing but the line joining A and B. Here we call that line as chord length of AB. Chord, that is chord length of AB we are going to calculate. How to calculate that chord length of AB? Okay. Now, what about this angle? Theta. I want to divide this chord length into two equal parts by joining a line or by drawing a line from O on to this chord. This line bisects AB into two parts. Let us assume this angle is theta by 2 and this angle is theta by 2. That is, this line bisects that angle also. Therefore, it is theta by 2, it also theta by 2. Assume it is M, this point M. Now, consider this triangle OAM. From the triangle OAM, now you consider the triangle OAM. From that triangle, use sine angle, that is sine theta by 2. Sine theta nothing but adjacent side divided by hypotenuse. What is, sorry, sine theta? Is it is adjacent side by hypotenuse? No. What it is? Opposite side divided by hypotenuse. It is opposite side divided by hypotenuse. What is the opposite side here? OM. Let us assume OM is equal to x. Therefore, MB also equal to x. Now, sin theta by 2, opposite side OM divided by hypotenuse OA. This is equal to, OM means x, OA nothing but r. So, x is equal to r sin theta by 2. X is equal to r sin theta by 2. But we want to calculate this total length. What is the total length? 2x. Now, 2x is equal to 2r sin theta by 2. That 2x is equal to 2r sin theta by 2. That means a particle moving along the circular path, it is moving along the circular path. When it travels from one point to the other point, then its radius subtends an angle theta at the center. The displacement travelled by the particle is equal to 2r sin theta by 2. That the displacement travelled by the particle is equal to 2r sin theta by 2. Remember that. Here, in case of distance or path length, in terms of theta, you must consider radians. You must consider radians. Okay. Next one. Observe this. Here, this is a situation. Observe this situation. Let us consider a ball. Let us consider a ball or a stone. I want to project that stone from the ground to a certain height. I want to project this stone in the upward direction. It is our common experience that as the ball moving in the upward direction, its velocity gradually decreases. Is it true or not? Its velocity gradually decreases. Already you know that force of gravity acts vertically downwards, so that its velocity gradually decreases, and after it reaches to this point B, its velocity becomes 0. Does it remains at that point? No. What happens to it? It wants to move in the downward direction along the same straight line. Along which line it is moving? Along that line it is moving in the downward direction. But for my convenience, I want to consider another line. Actually, it is moving along the same straight line, but for my convenience, I want to consider another line. Remember that. Okay. While you project this ball in the upward direction, what happens to its speed? Gradually decreases, and after it reaches to that point B, its speed or its velocity becomes 0. There onwards, it is moving in the downward direction, and it hit the ground, and it hit the ground, and it hit the point of projection. From where you are projected to that point, it reaches. Now, we want to calculate path length travelled by the particle. Tell me, what is the path length? Path length nothing but distance. What is meant by distance? Actual length of the path travelled by the particle. Now, what is actual length of the path travelled by the particle? It is AB plus BA. Total length of the path, AB plus BA. AB plus BA, that is distance or path length. Now, you tell me, what about the displacement? Displacement nothing but final position minus initial position. What is its final position? A. Initial position also A. Here, final position coincides with the initial position. So, displacement is equal to 0, because displacement means final position minus initial position, final position minus initial position, initial position, final position minus initial position. So, displacement is equal to 0, remember that. Okay, next one, observe this. Here another situation, let us assume it is the tower, okay, some tower. From top of the tower, a body projected in the upward direction. Let us assume a body projected in the upward direction from the top of the tower. I am assuming it is a tower whose height is equal to capital H. Our journey, that is for the initial point of this ball is A, that is top of the tower. Okay, from the top of the tower, a ball projected in the upward direction. As it is moving in the upward direction, what happens to its velocity? Decreases, and it reaches to certain maximum height. After it reaches to that maximum height, does it move further in the upward direction? No. Now, what happens to it? It wants to move in the downward direction along the same straight line. But here I am assuming that just it deviates from its path. It just deviates from its path. So, it just deviates from its path. Then it is moving in the downward direction and it hit the foot of the tower. It crosses the top of the tower because it just deviates from its path. So, it hit the ground. Is it true? It hit the ground. Now, for this complete journey, I am going to calculate path length, nothing but distance. Okay. Here, this height already they are given as x. That height is x, remember that. That means maximum height attained by that object above the top of the tower is x, remember that. Now, we want to calculate path length. What is meant by path length? Actual length of the path travelled by the particle. Actual length of the path AB plus BA plus AC. Actual length of the path nothing but AB plus BC plus CA for complete journey. Remember that. That is from A to C. First, I want to calculate A to C, that is for complete journey. For complete journey. For complete journey. That is from A to C. I want to calculate distance, that is AB plus BC plus AC. It is AC or CA. Okay, I will write it clearly. It is AC. It is equal to AC. Now, AC. Tell me, what about AB? X plus BC also x plus AC nothing but H, capital H. Therefore, it is equal to 2x plus capital H. 2x plus capital H. Observe this. That is for complete journey, that is from A to C. What is distance? 2x plus H. Now, you calculate displacement for that complete journey. Displacement for complete journey. Displacement nothing but final position minus initial position. For this complete journey, C is the final position, A is the initial position. Here I am assuming that it is y axis. For our coordinate system, known coordinate system, I want to consider it is y axis. Now, A is the initial point, it is the reference point, it is taken as origin. So, its coordinates are 0, 0. Above O, above reference point, above origin, it is positive y axis. Below the origin, it is negative y axis. Already we know it. Positive y axis and it is negative y axis. So, what are the coordinates of C? It is 0, minus h. Okay. 0, minus h. Why you are consider that minus h here? Because it is negative y axis. So, I want to consider its position is 0, minus h. Now, you calculate displacement along y axis. Final position how much? Minus h. Initial position 0. Therefore, displacement is equal to minus h minus 0, that is final position minus initial position. Remember that it is final position, it is initial position. Therefore, displacement becomes minus h. Okay. Now, for this journey A to A only, from A to A, distance travelled by the particle, nothing but actual length of the path travelled by the particle, means AB plus BA. That means x plus x becomes 2x, x plus x becomes 2x. Remember that. It is not x, distance is equal to 2x. Is it true? Actual length of the path travelled by the particle, it is x and this also x. Totally it becomes 2x. Remember that. Now, what is displacement? Displacement means, yes, it is final position minus initial position. For this journey, final position coincides with initial position. Final position coincides with the initial position. Therefore, displacement becomes 0. Displacement is equal to 0. Remember that. Okay. That I completed the path length and displacement applications. Now, I want to ask some questions from this class. Okay, I want to ask some questions. Observe these questions. Okay, just you observe this question. In the following, unit of work is, already you studied it in your 9th standard, also you studied it in the 10th standard. Just I want to recall those units. Now, what is the unit of work? Yes, it is joule. This is the correct one, not this one. Because it is capital J, it indicates scientist name. Joule is the scientist name, but if you want to use it as unit, first letter should be taken as small j. Already I discussed it in the last class. Remember that. This is the correct answer. Remember that. And next one. Observe this. What is SI unit of power? Power means work done divided by time. Power, rate of doing work, that is work done divided by time interval. Now, what is SI unit of work? Joule, capital J. Here I want to use it as the symbol. In case of the symbol, that should be taken as capital letter. Time small s, that is joule second inverse. Also we called it as watt. It is scientist name. On the honor of watt, we use the unit of power as watt, but here I want to represent it as a unit, therefore first letter is small letter, remember that. So, which is the unit here? This one is the correct one. Okay, next one. SI unit of pressure. What is meant by the pressure? Pressure nothing but force per unit area, that is force divided by area. Pressure nothing but force divided by area. Now, what is the SI unit of force? Newton, capital N, because I want to use it as a symbol. So, it is capital N divided by unit of area, meter square. So, it becomes Newton meter power minus 2 or Newton per meter square, or it can be written as in the full form Newton meter square, meter square. Now, you observe these things, which is the correct one? Oh, it is Pascal is also used, is the unit of pressure, Pascal, but here it is capital letter Pascal. If you want to use it as unit, first letter should be small letter. So, this is the correct answer. Next one, SI unit of time. Yes, that is the first one is the correct answer. Not it is SEC, not it is SEC, not it is SECOND. Here you must use a small letter. Second, you must use the small letter. Okay, don't use in this manner. This also wrong, but usually we write it as 2 seconds, 3 seconds like that, but it is not the standard representation. Remember that it is the standard representation. Next one, kilowatt hour is the unit of, already in our 10th standard you studied that. Once again I want to recall it. Okay, what is meant by kilowatt hour? Kilowatt hour, kilowatt hour, watt hour, or 1 kWh. 1 kilo means 10 to the power of 3. Kilo nothing but 10 to the power of 3. Watt nothing but joule divided by second. Unit of power, joule divided by second, work done divided by time, into hour. In terms of seconds, it is 60 into 60 seconds. 1 hour nothing but 60 into 60 seconds. Now, this S gets cancelled, it becomes 6 6s 36. 3600 into 10 to the power of 3 joule. Now, what is this joule indicates? Unit of energy or unit of work. Unit of energy or unit of work. Therefore, kilowatt hour is the unit of work or energy. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. 3.6 into 10 to the power of 3 into 10 to the power of 3. Total it becomes 3.6 into 10 to the power of 6 joules. Remember that. Okay, next one. Kg meter second inverse is the unit of. Already in your 9th standard you know about that. Force. What is meant by force? F is equal to ma, m kg, a meter second power minus 2. Linear momentum, mv, m nothing but kilogram, v nothing but meter second inverse. Therefore, which is the correct one? Linear momentum, not angular momentum and torque. I think you don't know about angular momentum and torque till now. We will discuss them in the later chapters. Okay, that is kg meter second inverse is the unit of linear momentum. Okay, here the quantity having the units of mass is, tell me, what is meant by impulse? Impulse, already in your 9th standard you know about that impulse also. It is change in momentum. Impulse nothing but change in momentum in magnitude. Change in momentum in magnitude. Change in momentum. Now, what is the SI unit of change in momentum? Just we observed in the previous question. It is kg meter second inverse. Small k it is. Kg meter second inverse. That means unit of mass kilogram. Unit of mass kilogram. But here impulse unit kg meter second inverse. Inertia. Tell me what is about inertia? I think you learned it in Newton's first law of motion, that is in laws of motion in your 9th standard. What is the inertia? Inertia nothing but it is the inherent property of a body which unable to change its state of rest or uniform motion. That is, to measure the inertia, which physical quantity we have to use? Mass. That is, mass is the measure of inertia. Already we know that mass is the measure of inertia. Measure of inertia. Mass is the measure of inertia. So, inertia is same unit as that of mass. That's why the correct option is second one, not moment of inertia and not density. I think you don't know moment of inertia. You don't know about this moment of inertia. Okay, what is meant by density? Mass divided by volume. Mass unit kilogram, volume unit meter cube. That means kg meter power minus 3. I am not discuss about this moment of inertia. Actually, we don't know that moment of inertia till now. But kg is not the unit of moment of inertia. So, what is the option? Second option is the correct one, because mass is the measure of inertia. Now, you will observe this problem. First, you observe this problem. What it is? In the above figure, a car moving along a straight line. Now, displacement of the car in moving from O to P is O to P. We are going to calculate displacement from O to P. Car moving from O to P. For that journey, we are going to calculate which one? Displacement. Now you tell me what is meant by the displacement. Huh? It is final position minus initial position. What is the final position for this journey? O to P. P is the final position, O is the initial position. Now difference between both of them, 360 minus 0. The difference is 360 minus 0. Okay. It is 360 minus 0. That difference. Therefore, it becomes how much? 360 meters. Difference between final position minus initial position, 360 minus 0. So, second option is the correct one. Okay. For this journey, tell me the distance, nothing but path length. Actual length of the path travelled by the particle is called distance or path length. Therefore, for this journey, path length or displacement is equal to how much? 360 meters. It also equal to 360 meters. Remember that. Okay, here in this question, displacement and path length are same. Why? Particle is moving along the same straight line. Here, particle is moving along the same straight line. Remember that. Okay, next observe this. Same diagram. Now again you observe this. In the above figure, a car moving along a straight line. Now displacement and the distance travelled by the car in moving from P to Q. In moving from P to Q, observe that. First, I want to calculate displacement in moving from P to Q. Just you observe that. It wants to travel from P to Q only in this manner. It wants to travel. For that journey, we are going to calculate which one first? Displacement. What is meant by the displacement here? Tell me what is meant by the displacement. Final position minus initial position. For this journey, what is the final position? 240 meter is the final position. I want to consider these values are in system international. Okay, I will put them also. 120 meter, 0 meter, 240 meter, 360 meter. Okay, now we want to calculate displacement, final position minus initial position. For this journey, 240 meter is the final position. Now, what about initial position? 360 meter. Now, answer becomes how much? Minus 120 meter. Minus 120 meter. Now, think about distance travelled by the particle. Now, you think about distance travelled by the particle. Distance nothing but length of the path travelled by the particle. Actual length of the path travelled by the particle. Now, just you measure this length. What about this length? I think it is 120 meter. Is it correct or not? Just length of this path, just length of that path, which is equal to 120 meter. You measure only length of this path. It is equal to 120 meter. So, which option is correct? Minus 120 comma 120. First it is displacement and next one distance. Okay. Next, observe this. Now, same figure again. Again I want to consider those values are in system international 0 meter, 240 meter, 360 meter. Okay. Now, which one here you want to calculate? A car moving along a straight line. Now, we want to find out the displacement and distance travelled by the particle. In moving from O to P and from P to Q, we are going to calculate first displacement. O to, it travels from O to P and then from P to Q. Okay? Listen to me. It travels from O to P and then P to Q, and then it reaches to Q. That is, its final position is Q, initial position O. This is initial position and it is final position. Now, we want to calculate displacement covered by the particle. Displacement covered by the particle. How to calculate that displacement here? Final position minus initial position. What is final position? 240 meter. Initial position 0. So, displacement becomes 240 meter. Displacement becomes 240 meter. What about distance? What about distance travelled by the particle, or path length of the particle? Path length, actual length of the path travelled by the particle. Here, actual length of the path travelled by the particle, this one we are going to calculate. From here to here, how much length? 360 plus from here to here, how much it is? 120. From here to here, how much its length? 120. So, it becomes 480 meter. 480 meter. So, answer is second option, 240 meter, comma 480 meter. Next one. Observe this. Consider a particle moving from A to B in a circular path, of radius 2 meter as shown. Then displacement of it is. Okay. Observe that. Consider a particle moving from A to B in a circular path of radius 2 meter. Its radius is equal to 2 meter. Particle moves from A to B. A to B. Here it moves from A to B. Now, which one you are going to calculate? Displacement. Here you are going to calculate displacement. Now, you tell me how to calculate displacement. How to calculate the displacement? Final position minus initial position. What is final position? B. Initial position? A. If you assume it is x axis, tell me the coordinates of A, 0 or 0 comma 0, or you can assume it as 0. Now, what are the coordinates of B? Yes, 2 meter plus 2 meter. 4 meter. It is 4 meter. It is 0 meter. Therefore, displacement means final position minus initial position. That is 4 meter minus 0 meter, it is equal to 4 meter. This is the answer. Now, you tell me what is the distance travelled by the particle. Here in this question it is not given, but I want to calculate distance also. Actual length of the path travelled by the particle. Here we are going to calculate actual length of the path travelled by the particle. Okay, what about this length? Here particle moving along the circumference of a circle. Is it true or not? It is moving along the circumference of a circle. So, its path length nothing but half of the circumference, because it wants to travel from A to B only. Therefore, distance is equal to 2 pi r divided by 2, that is equal to pi r, or it is equal to pi into 2 meter, that is equal to 2 pi meters. Remember that. Okay, here in SI units, in case of SI units, remember that in case of SI units, pi is equal to 3.14. You consider pi as 3.14. It is the standard value of pi. Pi means 22 by 7, which is approximately equal to 3.14. Remember that. Next one. Observe this diagram. What it is? As shown in this figure, a particle moving from A to B along a circle A to B, along a circle of radius 1 meter. Now we want to find out its distance and displacement. Distance and displacement we want to calculate. Remember that. Distance and displacement we are going to calculate. From where to where it wants to travel? From A to B only. A to B it wants to travel. Now, for that journey, first I want to calculate distance, then after that displacement. Okay. Distance first. Distance nothing but actual length of the path travelled by the particle. Tell me, it is moving along the circumference of a circle. Therefore, this length becomes 1/4 of its circumference. Complete 2 pi r, but in that 1/4 only we want to calculate. 1/4 only we want to calculate. Therefore, it is 2 pi r divided by 4, that is pi r divided by 2, which is equal to pi into, what is the radius here? 1 meter. They are given that radius is equal to 1 meter. Pi into 1 divided by 2, that is equal to pi by 2 meter. Now we are going to calculate displacement travelled by the particle. Observe that. Displacement. Here already we derived one formula to calculate the displacement when the particle moving along the circumference of a circle. Here you observe that particle travels from A to B such that its radius subtends an angle at the center. How much that angle? Pi by 2. How much that angle? Pi by 2, 90 degrees. 90 degrees nothing but pi by 2 radians. Remember that. It subtends an angle 90 degrees. Here pi radians means 180 degrees. 2 pi radians nothing but 360 degrees. So pi by 2 nothing but 90 degrees. Pi by 2 nothing but 90 degrees. Okay, here 90 degrees I want to consider it as pi by 2. Now while the particle moving along the circumference of a circle, its radius subtends an angle theta at the center of the circle, then the displacement covered by that particle can be calculated by using the formula 2r sin theta by 2. Already we derived this formula 2r sin theta by 2, that is equal to 2 into here radius. Okay, you will assume that radius r as small letter, that is 2r sin theta by 2. I am sorry, it is 2r sin theta by 2. R is equal to how much? 1 sin theta. Theta is given as pi by 2. Pi by 2 nothing but 90 degrees. 90 degrees divided by 2, that is 2 into sin 90 by 2 means sin 45. Tell me what is the value of sin 45 degrees? Already in trigonometry you know about that value. What is the value of sin 45 degrees? Yes, it is 1 by root 2 meters. Sorry, 1 by root 2 sin 45. 2 into 1 by root 2. 2 divided by root 2 becomes root 2, because 2 can be taken as root 2 into root 2. So it becomes root 2 meters. So answer is first option, pi by 2 meter comma root 2 meter. Okay, next one. Observe this as shown in this figure, same figure. A particle moving from A to A along a circle of radius 1 meter, then we are going to calculate distance and displacement. We are going to calculate distance and displacement. Here particle travels from A to A. That means it complete one revolution. That particle completes one revolution, A to A. What is radius of that circle? 1 meter. Now we are going to calculate its distance. First I want to calculate its distance. Distance nothing but actual length of the path travelled by the particle. Actual length of the path travelled by the particle. Now this length is equal to how much? The total length, nothing but circumference. So it is equal to 2 pi r. So it becomes 2 pi into 1 meter, that is equal to 2 pi meter. A to A, complete revolution. What is about displacement? What about displacement? Tell me, what about displacement? Final position minus initial position. Here both coincides with each other. Both coincides with each other. So displacement nothing but 0 meter. I think it is the answer. Okay. Complete journey. For complete journey, total length of the path 2 pi r. Remember that. Displacement final minus initial, so it becomes 0 meter. Next one. Observe this. Already we derived that condition for this type of problem. Now, a particle moves over an arc PQ, of a circle of radius capital R, circle of radius, its radius capital R, subtending an angle 60 degrees at the center as shown in figure. Then we are going to find out its displacement. Here particle travels from P to Q only. Already we derived the condition for it, the formula for it. A particle travels from one point to the another point along the circumference of a circle, so that its radius makes an angle theta at the center. Its displacement is equal to 2r sin theta by 2. Its displacement is equal to 2r sin theta by 2. That result here I want to use. What is displacement? Displacement 2r sin theta by 2. It is 2r sin theta by 2, that is equal to 2r sin theta, nothing but 60 degrees divided by 2, sin 60 degrees divided by 2. Then it is equal to 2r sin 60 by 2 means sin 30 degrees, that is equal to 2r sin 30 1 divided by 2, which is equal to capital R. 2 gets cancelled, sin 30 nothing but 1 by 2. So, answer becomes R. Now, you tell me what is meant by the distance in this question. What is the value of distance? What is the value of distance covered by the particle? Yes, actual length of the path travelled by the particle. What is actual length of the path travelled by the particle? Tell me. What is actual length of the path travelled by the particle? Already we derived one result for this question, that is arc length. Distance nothing but arc length of PQ, arc length of PQ. What is its arc length? Yes, it is pi into R. And then, sorry, is it true? Is it is pi into R? Okay, just you observe that. I think it is wrong. How much it is? Yes, it is R into theta. R into theta. Its arc length is equal to R into theta. That is R into theta means how much here? Don't substitute it in terms of degrees. You must substitute it in terms of radians. So, 60 degree nothing but pi by 3. Is it correct or not? You will check it. Pi means 180 degrees. 180 divided by 3, 60 degrees. 180 divided by 3 becomes 60 degrees. So, it becomes pi by 3, that is pi r divided by 3. Pi r divided by 3. That is distance is equal to pi r by 3. You remember that in this formula r into theta, you must substitute theta in terms of radians. Remember that thing. Okay, next one. A person walks from A to B and from B to C, shown in that figure. Then his distance we want to calculate. Where to where he wants to travel? A to B first, A to B, and then from B to C, B to C. Now, for that journey distance, a very simple one. Distance nothing but actual length of the path travelled by the particle. Distance nothing but actual length of the path travelled by the particle. Now, what is actual length of the path travelled by the particle? Tell me. 3 plus 5, that is equal to 8 meters. Okay. Okay. I think you understood about path length and displacement covered by a particle. Remember both the definitions. With respect to the definitions, we do the problems. Remember that. Okay. I want to close this session. Thank you very much. Please subscribe our channel, that is Vignan Junior College. Thank you very much.